You probably heard about the AI agents, but can't understand what does it mean when the AI acts as an agent. In this video I will show you how a local LLM Gemma 431b can interact with the multiple tools, extract the external data, write code, connect to the little-known API, and much more. But first of all, I want to explain to you what's function or tool calling. I will tell you only the key idea. Please don't omit this section. I will try to be as short as only possible. Function or tool calling is a complete switch of the paradigm on how we interact with the AI. The old paradigm is as follows. We tell the model what to do. For example, we ask the model to write an article, and the model does the job. In the new approach, we are giving the model a specific task and providing multiple instruments or tools, and the model makes a decision which instrument to use to solve this task. I will repeat this one more time, since most of people, even who run the AI YouTube channels, omit this crucial detail. In other words, we delegate decision making to the model. Let me give you the simplest example. Most of you have seen how the model is searching the internet, and you don't see any magic in this action, but the magic is behind the scene. Previously you activated the search capability by turning on some switcher or clicking the special search icon. But the modern AI models do it another way. You don't switch anything in the interface. Instead, the model makes a decision to search the internet when it realizes that it doesn't have enough data on the subject. Another example is an AI coder. You don't ask the model to write a function on Python. Instead, you give the model a task, and the AI model decides itself how to solve it by writing the code. So you can't build your personal agentic system if you don't understand the difference. So let me introduce my agentic setup. I use OpenWebUI as my graphic user interface. I use OpenCode as an IDE, and my agentic environment is powered by Gemma 431b running locally. Also worth noting that I use OpenTerminal to provide to the model the capability to access my hard drive, to run the commands in the isolated environment. I will try to give you some simple examples of the real use cases of the AI agents. This is an introduction video to the broad subject of the AI agents, so if you want the extended version of this video with the long tail details, let me know in the comments. Let's first ask the model to give us the list of the instruments available. Let's now take a look what the model can do. Here is the list. Web and information retrieval, system and file operations, memory and knowledge management, personal data management, entertainment, and other utilities. In your basic subscription, such as ChatGPT or Claude, you probably have many of these instruments activated. But I can show you that you can set up almost any tool for your personal and business needs in your local environment. For example, let's ask the model something it doesn't know. We ask the model about itself. It's funny, but Gemma 431b knows nothing about Gemma 431b, as its knowledge cutoff is dated January 2025. Let me show you what's going on under the hood. In the model's chain of thought, we see that the model doubts in its actual knowledge and thereby makes its own decision to search the internet. What the model is doing right now, it's calling a tool named Search Simple. How does this tool work? I made a Python script at the backend of my OpenWebUI interface, which makes a request to a search engine, so the model will receive a top 10 search results. Next, the model calls another tool called Extract Content to grab the data from the web page. When you ask the model to do that using your ChatGPT subscription, the model makes the tool calling multiple times. It collects the data from 3 to 10 sources and gives you a summarization on this information. But unlike this direct approach, my agent can do the job better. Instead of requesting each URL and grab all the data in the context window, my agent can call the tool named search word knowledge. This tool presents my RAG plus MMR pipeline. In short, the agent only gets the list of top 10 URLs from the search engine result page and doesn't put all the data in the context. At the backend, my system extracts the content, cuts it to the chunks, puts these chunks into the vector database, for example, phase, and makes a re-ranking of these chunks after embedding. And the model will get the extract of knowledge after the pre-production. What is the difference between the two tools? The model is using search simple in the case when we need to extract the data from a single page. Search word knowledge is used when the model requires to extract the content from the multiple sources. But the benefit of the second approach is that the model is not using the precious context window working with the massive data. The dirty job is happening on the backend. It's a very big difference that few people understand. We save context by allowing the model to select the right tool. Now, when you see the difference, let me briefly explore my other tools. My agent can directly connect to Wikipedia. We thereby avoid multiple requests to the search engine. Let's ask the model about some little-known historical personality. As we can see some mistakes in the answer. In our case, the model has been wrong about the birth and death dates. We will ask it to verify the answer using the Wikipedia tool. My agent can query Wikigraph called Wikidata. Now we will ask the model to make a test request to a Wikidata. It's a knowledge graph of Wikipedia. And now we see the result of the SPARQL query made by the model. We can also ask the model to search for some scientific paper and give us more details, for example, about quantum computers. Another feature of my stack is direct access to the archive.org API. I will ask the model to retrieve the data about Christian Huygens and find its famous book. Also, we will ask the model to retrieve some precise data and make mathematical calculations. As you can see, Gemma 4 makes a request to the Wolfram Alpha API for this data. We need this if we want to calculate something preciously and don't want to rely on the model. Yes, I don't want to make this video too long. Let me show you only one feature from this stack called YouTube search, because you're now on my YouTube channel. Let's ask the model to analyze some video. Let it be my video about how I managed to run this model Gemma 4 31B on a 9-year-old NVIDIA Tesla V100. I will give my model a link to this video and ask you to make a summarization and emphasize the key aspects of this video. As you can see, the model did the job. If you are not sure about what video you are willing to watch, you can ask the model to make the decision for you. It's amazing, isn't it? Let me show you how the model can help you to entertain. For example, I want to know about one of my favorite TV shows named Silo. The model doesn't know about this series given its knowledge cutoff, but I can connect my agent to the special TV and movies API, so the model can extract not only the description of the show but also navigate through its episodes and tell you what exactly happened to the protagonists. As you can see, the model is using multiple instruments to achieve the goal. It's a flexible approach. The model can make a request to my tool called Search TV Shows to find the TV show named Silo. Then it calls another tool named Get TV Shows Details to get a synopsis. Next, I will ask the model to give me more details about the show. And the model can choose between browsing the internet via search simple or call search Wikipedia and the next call get Wikipedia page to give me the extended data. Finally, we can ask the model what happened in a particular episode of the TV show, and Gemma 4 would call another instrument named Get TV Show Episodes and then another one called Get Episode Details. My agent can also execute code directly in this session. Let's ask the model to test this feature. You see that the model successfully created a file in a test folder in my sandbox. Then we ask the model to run some code. As you can see, Gemma 4 created a simple Python code and executed it. Finally, let's ask the model to interact with the database and retrieve some information from it. And it's clear now that Gemma 4 can execute SQL queries and return results. And we tested all these features in the safe environment. I hope this short demonstration is enough to realize that Gemma 4 launched locally can interact with your hard drive and operate your private data. And your favorite part is using the agent for vibe coding. In my case, I will use an open source application named OpenCode. I set up my local Gemma 4 31B and now it can work with my projects. I can write code from scratch and manage my current code base. Just for demonstration, let the model take a look inside my project and explain to us what's the key idea behind this project. As we can see, Gemma 4 analyzed my RAG pipeline and now it's ready to work with my code. In this video, I don't want to waste your time by showing you how the model deals with my code base. Most of you know such applications like Cursor or Anti-Gravity by Google and so on. My goal is to show you that the same model run locally can serve one of its parallel requests to write and analyze your code. My agent can get access to the current date. It can browse the history of my chats with Gemma 4 and other models. It can create and change nodes, save data to the local and remote databases, get any process status, chunk documents, connect to the vector database, and much more. And the best thing in all of this is that my agent powered by Gemma 4 31B can get access to the new instruments. Tomorrow I could have a new brilliant idea, and all I need to do is to write some piece of code to provide my agent this new superpower. Let's be honest, can any API give us such a huge stack of tools for an agent? Honestly, what's your answer? My answer is that there is not a single AI solution in the market with this stack of capabilities. I've been trying to make this video as short as only possible. We just briefly explored what my agent powered by Gemma 4 31B or any other model can do. And yes, I'm not mistaken, I can connect any model, whether it be local or the one via API, to my stack of tools. I can switch between the models, I can choose any of them. I just want to keep my privacy and be independent. If you want to know more about how a particular tool of this stack works, how I connected all these tools to my OpenWebUI graphic user interface. Leave me a comment and I will record a technical video on the subject. Thank you for watching. I hope this video was useful for people who build a private environment for personal and business needs. I want to show you that a local model placed in the right environment can give you the power comparable to the cloud API providers and even surpass them. Subscribe to my channel or watch my other technical videos where I showcase my secrets of local inference.